The second question deals with proportions, so it is a chapter 16 and 17 question. It has both hypothesis testing and confidence intervals and focuses on the link between hypothesis testing and confidence intervals. In this question, you will show how a test can be performed with a confidence interval. Make sure to note that when we perform a test using a confidence interval, it is a two-sided test, a does not equals test, where the alpha level is 1 minus the confidence level. You'll see that here in this question. So we went around asking UT students if they recycle, and we specifically asked sophomores. It is believed that 75% of them recycle, and we have 5,000 sophomores at UT. So we went out and researched 128 of them and found that 84 of them said they recycle regularly. And those are the kind of key numbers we need. We also need to know that we randomly selected these individuals, which is very important for one of our conditions. And as the problem states, they were randomly selected from UT sophomores. So let's go ahead and check our three conditions. Our first condition is random. As with any testing or confidence intervals, we need a random sample. And the problem says it's random. And that's how you know it's random, is if the problem says it's random. I can't say that enough. If it doesn't say it's random, do not say it's random. This problem specifically stated that the sophomores were randomly selected. Next, we have the 10% condition. Now, how could we justify the 10% condition? The 10% condition is that we need to sample less than 10% of the population. So think about that for a moment. In the problem, we state that there were 5,000 UT sophomores. With about 5,000 UT sophomores, we sampled 128. 10% would be 500. 128 is less than 10% of the 5,000 UT sophomores. And you could do a lot of different things right here. You could just divide 128 by 5,000 and show that it's a much smaller percent than 10%. Or you could say 500 is 10% and 128 is smaller, thus is less than 10% of UT sophomores. Just make sure to be clear and concise and show that we have sampled less than 10% of all UT sophomores. Now the last one is where you have to pause and think. This is a chapter with proportions. Since it is proportions, we have the success-failure condition. Specifically, when making a confidence interval, we need to pass the NP hat, NQ hat condition. And what NP hat and NQ hat actually mean for this third condition, the success-failure condition, is that we have at least 10 successes in the sample and we have at least 10 failures in the sample. And you'll notice we have 84 successes in the sample out of 128. Well, that means we have 44 failures. Because if there's 84 successes, there's 44 failures. And failures and successes are just meant for the yeses and nos. We had 84 people who said they recycle and 44 people who said they don't. So thus we have more than 10 successes and more than 10 failures, and we pass the condition. All these conditions must be met so that we can use the normal distribution here. If we don't meet these conditions, then we can't use our normal methods, and that doesn't work for our confidence intervals and our hypothesis testing, and we are doing things incorrectly. So let's continue on here. So regardless of whether we met those conditions or not, and we did meet all three conditions, use all the information to create a 93% confidence interval. And remember, people often ask, will you be giving us the Z's? And the answer is yes. We generally want you to know that a 95% confidence interval is basically 2. To be specific, it's 1.96, but 2 is what most people generally use to compute it because we let software compute it more exactly when we actually want to compute it correctly. But with that in mind, we will give you the Z-score when we want something like a 93 or a 90. 90 would be 1.645. Lots of them. We have a 99% confidence interval, 2.5758, but we would be giving you these numbers. And so here we have a 93% confidence interval with 1.812, and I could not have told you that one off the top of my head because no one usually wants a 93% confidence interval. They want a 90, 95, or 99. So with that in mind, let's go ahead and do the formula right here. Now remember, for this formula, you will have a formula page, but all confidence intervals will have the sample statistic first. In this instance, it's p hat. And then we'll have plus or minus, because now we're to the margin of error. We have the z-score, which is given here of 1.812. Next, we have p hat times q hat over n square root. And once we multiply everything together, we will get our interval from 58 to 73.2. And so you'll notice something about this interval. This is a 93% confidence interval, and we are 93% confident that the true proportion of UT sophomores that recycle is contained in the interval 58% to 73.2%. And with that in mind, we've just interpreted it correctly, and you'll notice a very specific format to this interpretation. I am blank percent confident that the blank is contained in the interval blank to blank. And the hardest part for people is that second part, because it's what are you estimating? The first part and the third part are easy, but interpreting this interval right here is where you really have to make sure you get the second part correctly. We're always trying to understand a true something, and this true something is for the population. So you could say the population proportion, but we generally just say true. It's synonymous. The true proportion of UT sophomores that recycle. And that was why we sampled some to figure out what's the true proportion of UT sophomores that recycle. So with that in mind, we wanted to know if it was 75%. And what do you notice about our interval? Our interval does not contain 75%. That's going to come into play here in a moment. So on to our next question. Suppose the researcher wishes to carry out a formal hypothesis test, write out the null and alternative hypothesis they wish to test here. So they wanted to see if it was 75%. Their alternative would simply be that it's not 75%. So remember, we're testing proportions here. So if you read it as a sentence, we would have the null states that the true proportion of UT sophomores that recycle is equal to 75%. The alternative states that the true proportion of UT sophomores that recycle is not equal to 75%. With that in mind, we just need to simply put it into notation now. We will now have the null states as HO colon, then we need the true proportion, which will be P, equals 75%. The next part for the alternative is not too hard either. The alternative states HA colon, now we need the true proportion of UT sophomores. Finally, it does not equal to 75%. And we have stated the null and alternative in statistical notation. And this is something big to practice up on. There's only a few ways to write it out, and remember, the null always has the equal sign. The alternative can have a less than, greater than, or does not equals to, just depending on what the question tells you. Always look to the question for the alternative. In this question, they wanted to see if it was equal to 75, so if it's not equal, they would have evidence it's not equal. They just wanted to see if it was 75, and they're looking to see if it is or is not 75. We can actually do a hypothesis test on this without doing the hypothesis test. So let's go ahead and use our interval from before, which went from 58 to 73.2. And you'll notice the one we give you down here at the bottom is very similar. It does not contain 75. It might not be very close to your interval, but it also has the same sort of relationship that it does not contain 75. So would you reject the null or fail to reject the null? Remember what you said earlier. I am 93% confident that the true proportion of UT sophomores that recycle is contained in the interval 58 to 73.2%. So I don't think 75 is the truth. So I would reject the null because the null says 75 is true. What does that mean? I reject the null and I have evidence for the alternative. Now, going back to our null and alternative, let's state it in context of the problem. I reject the null that the true proportion of UT students that recycle is equal to 75%. I have evidence, due to my confidence interval, that the true proportion of UT students that recycle is not equal to 75%. And if you notice, anytime it asks for in context of the problem, all I have to do is say, I reject the null. I have evidence for the alternative. Now, if 75 had been in the interval, I would have to say, I fail to reject the null. I do not have evidence for the alternative. And all you have to do is then state your null and alternative again. So make sure to know how to say things in context of the problem. It all goes back to how you wrote your null and your alternative. Finally, just to bring it all together, when we do a hypothesis test using a confidence interval, we have to know at what alpha level we were actually doing that hypothesis test. Since this is a 93% confidence interval, remember that confidence intervals and tests are just like each other. Because, since this is a 93% confidence interval, it'll have an associated alpha level. This associated alpha level is always 1 minus the confidence level. And since the confidence level is 0.93, the alpha level for the two-tailed test is 0.07.